Good morning, ladies. Today is Wednesday, March 25th, and our CGI lesson today is going to be about Manny and his basketball cards. So Manny owns 83 sets of basketball cards. Each set has exactly 504 cards. What is the total number of basketball cards Manny owns? All right, so I'm going to read it one more time, and this time I really want you to focus in on those quantities and what they represent. Also, what are some clue words that you're noticing in the problem that also kind of help us better understand what it is that we should be doing in order to solve the problem? Is there any important information that maybe we want to highlight? Is there any information that might be irrelevant to the problem? So when you're listening this time, I want you to be thinking about what are some of those quantities and what do they represent. So Manny owns 83 sets of basketball cards. Each set has exactly 504 cards. What is the total number of basketball cards Manny owns? All right, so first thing I'm noticing is Manny has 83 sets of basketball cards. And then he has 504 cards in each of those sets. So another important word that we might want to make sure that we are highlighting is each set. And then also that it has exactly 504 cards. And then our question is also super important, where it's asking us how many, so what is the total number of basketball cards that Manny owns? And we want to know that total number of basketball cards that Manny owns. All right, so Manny owns 83 sets of basketball cards. Each set has exactly 504 cards. What is the total number of basketball cards that Manny owns? All right, so we marked up the text and kind of highlighted some of those important pieces of information and quantities. So now I want you to think about what you're going to do with each of those. What are you going to be doing with those 83 sets of basketball cards that have exactly 504 cards in each set to help us better understand or solve for the total number of basketball cards that Manny owns? So at this point, I want you to be using your CGI strategies. You're going to be going through solving this problem, planning out your plan section by identifying what your quantities are and what they represent, creating a number sentence with your variable. Remember, your variable represents your answer, whatever is unknown, identifying what that variable is. So if you're listing it as A equals apples. In that solving section, making sure that you are working through this problem and checking each step that you do. And remember, in that checking section, you can either use a different strategy using the same operation, or you can also use the opposite operation to check your work. So at this point, I want you to go ahead and pause the video. You're going to be solving this on your own, and then check back and we will solve the problem together and go over a couple strategies. So at this point, you should have already solved the problem about Manny and his basketball card. So I have listed our quantities up on them. So there were 83 total and 504 total number of basketball cards in one set. So let's think about kind of how we're going to be using these. Each set has exactly 504 cards. Each set has 504 cards. Each is important. And we know each can either mean multiplication or, so we want to kind of figure out, do we our answer to get bigger? Do we have our total? Do we know how many cards Manny has? Or are we trying to make equal sets of basketball cards using the 504 and the 83? So Our question was asking us how many cards, so how many total cards he has. One set of cards, and there are 83 sets. That means we want to get quite a bit bigger. So looking between these two operations, multiplying is going to cause our answer to get bigger. So we want to be multiplying. So in order to multiply these two numbers, several different strategies that we can be using. I'm going to show you three. The first strategy that we're doing in class, and a lot of us are most comfortable with, 504. And then I'm going to be multiplying that by 83. Okay, and then when I'm going through, I'm going to be multiplying each of these sections. 4 times 8 is 32. 8 times 0 is 0. 8 times 5 is 4 times 3 is 12. 3 times 0 is 0. Times 5 is 15. Now we're going to go through and we're going to be adding each of these columns or each of these diagonals. We have 2. 2 plus 1 is 3. 5 plus 3 is 8. 1 plus 0 is 1. And then 4. So right now I have an answer of 41,832. So let's use a different strategy to see if we are correct. So the next strategy I'm going to use is going to be the partial products method. So we're going to be taking 500, and then we have 0, and then we have 4. And then we have 80, and we have 3. And we're going to be doing kind of similar to what we just did with lattice, and we're going to be multiplying these numbers together. So 8 times 4, 8 times 40, adding our 3 zeros. 80 times 0 is 0. 8 times 4 is 32, add your 0. 3 times 5 is 15, add your 2 zeros. 3 times 0 is 0. 3 times 4 is 12. Now we're going to be adding all of these numbers together. So I'm going to stack all of these numbers so that we can add them. So I have 40,000, 1,500, and you want to make sure that you are lining up 320 and 12. I'm not going to include the zeros because they're not going to my answer. 2 plus 1 is 3, 5 plus 3 is 8, 1 plus 0 is 3. And we get an answer of 4,830 is the same. The strategy that I'm going to use is going to be the standard algorithm, which is going to be a little bit more challenging and have quite a few more steps. So starting with 504 on the top, and we're going to multiply it by 83. So I'll do each step in a different color. 3 times 4 is 12. 3 times 0 is 0, plus 1 is 1. 3 times 5 is 15. So we took our 3 times each of these digits, and now we're going to move on to the 8. 8 4 is 32. We want to make sure we put up our placeholder here, which is going to be a 0 because we're starting underneath the 8. So we want to make sure that that 2 goes under the 8. 8 times 0 is 0, plus 3 is 3. 8 times 5 is 40. And then let's add. We have 2. 1 plus 2 is 3. 5 plus 3 is 8. 1 plus 0 is 1. And then we'll bring down our 4. One way to check our work, if we wanted to use something other than multiplication, because we did just try 3 different strategies, we could do the opposite, which is going to be division. If I'm doing division, I'm going to be taking my answer and dividing it by the 83. Let me grab a different piece of paper so I have a little bit more space. Put it right here. All right, so I'm going to start with my answer, my product on the inside. So we have 41,832, and we're dividing that by 83. We know that 83 can't go into 4. We know that 83 can't go into 41. So we want to check and see how many times 83 can go into 418. And what I recommend doing is looking at this number right here and checking to see if this is going to be 5. So 83 times 5 gives me something close to 418. And I'm going to use my calculator because I'm running out of space. So 83 times 5 gives me 415. So then that would be something that's super close. Put a 5 here. We're going to subtract. 5 is 3. 3 more 3. We know 83 cannot go into 33. So we don't just stop or bring something else down. 0. 83 times 0 is 0. We subtract and bring down our 2. So now we want to be using this 4. We want to check and see if 83 times 4 gives me 332. And if you check, it does. So this would be 4. Is 332. We subtract and get 0, which means that we are correct. So our answer would be 41,832 basketball cards. Basketball cards is our unit, which is super important. We want to know, are we talking about apples? Are we talking about oranges? Are we talking about trucks or trains? We're talking about basketball cards. And then for our problem, for that number sentence that matches our word problem, I would do 504 times 83 equals 41,832. All right. Make sure that you double check that your work matches mine. And if it doesn't, go back and make sure that you're fixing it so that you have the correct answer. And then check back tomorrow for another CGI lesson. Have a great day.